When most people hear nuclear energy, they think of huge, expensive plants with long delays, radioactive waste, and high risks. But what if there was a new type of nuclear reactor, backed by one of the world's most influential tech entrepreneurs, that could change everything we know about energy? Welcome to the Natrium Reactor, the brainchild of TerraPower. And yes, Bill Gates is at the center of it. On Innovation Corner with Dan, today we're taking you inside this ambitious project, exploring how it works, why it matters, and what it could mean for the future of energy. Nuclear energy has been around for decades, but it's often been criticized for being slow, costly, and dangerous. Traditional reactors take years, sometimes decades, to build, and the financial and regulatory hurdles make them an uphill battle. That's why TerraPower, the company co-founded by Bill Gates, is trying to rewrite the nuclear rulebook. Their goal is not just to produce clean energy, but to do it faster, safer, and more efficiently than anything that exists today. The Natrium Reactor represents the next generation of nuclear technology. It combines advanced fuels, innovative reactor design, and a hybrid energy storage system to deliver a solution that could be a game changer for the US and the world. But how does it work, and why is it suddenly making headlines in 2025? Let's break it down. TerraPower, the vision. TerraPower began with a simple question: can we make nuclear energy safer, more affordable, and scalable for the modern grid? Bill Gates recognized that the world's demand for clean energy is growing faster than traditional nuclear could handle. Renewable sources like wind and solar are excellent, but they are intermittent. When the sun doesn't shine or the wind doesn't blow, we still need reliable power. That's where Natrium comes in. TerraPower's vision isn't just building reactors, it's building a complete ecosystem. They're thinking about how plants can integrate with modern energy grids, store energy efficiently, and operate with minimal risk. The Natrium Reactor is the centerpiece of this vision, a scalable, flexible nuclear system that can respond to the dynamic needs of energy grids. How the Natrium Reactor works at its core: the Natrium Reactor is a sodium-cooled fast reactor. Unlike traditional reactors that use water for cooling, sodium allows the reactor to operate at higher temperatures without pressurization, making the system more efficient and safer. Higher temperatures mean more energy can be extracted from the fuel, reducing waste and increasing output. But that's not all. TerraPower pairs the reactor with an innovative molten salt energy storage system. Think of it like a gigantic battery that can store heat produced by the reactor. When demand spikes, this stored energy can be released almost instantly, giving the grid a flexible and reliable power supply. This feature allows Natrium plants to match the dynamic behavior of modern grids, a key advantage over traditional nuclear plants. Safety is also a central focus. The reactor is designed to be passively safe, meaning that in the event of a malfunction, natural physical laws, like convection, automatically cool the reactor without requiring human intervention or active mechanical system. This drastically reduces the risk of accident and makes the plant more resilient. Why 2025 is a turning point. After years of research and development, TerraPower is finally breaking ground on its first commercial Natrium reactor. This isn't just another demonstration project, it's a real plant that will feed power into the grid. The timing is significant. Governments around the world are doubling down on clean energy, and utilities are looking for solutions that can reliably meet demand while reducing carbon emissions. In the US, energy demand continues to grow, and existing nuclear plants are aging. Many reactors are being retired due to high maintenance costs and outdated technology. Natrium offers a path forward: smaller, safer, and more adaptable nuclear power plant that can complement renewable energy sources rather than compete with them. The economics of Natrium. One of the main criticisms of nuclear energy has always been cost. Large, traditional reactors often cost tens of billions of dollars and take a decade or more to build. Natrium aims to change that with a modular approach. Components can be manufactured off-site and assembled faster, which reduces construction time and cost. Moreover, the combination of reactor and storage system allows the plant to provide grid services beyond just energy generation. By storing excess heat and releasing it when needed, Natrium can help stabilize the grid, reduce blackouts, and provide peak power exactly when it's needed, services that utilities are willing to pay a premium for. Investors like Bill Gates are betting on this model because it could finally make make nuclear energy economically competitive, even without heavy government subsidies. If TerraPower succeeds, it could open the door for a new era of nuclear power worldwide. Environmental impact. Unlike fossil fuels, natrium reactors produce zero carbon emissions during operation. They also generate less long-lived radioactive waste compared to traditional reactors, thanks to advanced fuel technology. The combination of safety, efficiency, and reduced waste positions natrium as one of the cleanest nuclear options available. In a world racing to combat climate change, the environmental implications are enormous. A single natrium plant can provide reliable electricity for hundreds of thousands of homes while dramatically cutting emissions, something solar and wind alone cannot always guarantee due to their intermittency. Challenges ahead. Of course, no technology is without hurdles. Nuclear energy still faces public skepticism, regulatory scrutiny, and the technical challenges of scaling a new design. Sodium cooling. While efficient, is highly reactive with water, meaning careful engineering and robust safety measures are crucial. Additionally, while natrium promises to be faster and cheaper than traditional reactors, it's still a multi-billion-dollar project. Delays, cost overruns, or technical setbacks could affect the perception of the technology. TerraPower has a lot riding on this first commercial project. It's essentially the test case for the entire natrium model. Why this matters globally. If successful, TerraPower's natrium reactor could redefine nuclear power around the world. Smaller, safer, and flexible reactors could replace aging coal and gas plants, complement renewable energy, and provide countries with a scalable solution to their energy needs. It could also inspire further innovation in modular reactor technology, energy storage, and grid integration. We see this as more than just a single project. It's a blueprint for the future of energy. It's a technology that could make nuclear power accessible, flexible, and environmentally responsible while meeting the urgent demand for clean electricity. The Bill Gates factor. Bill Gates is more than a financier. He is a visionary driving TerraPower's mission. His involvement brings credibility, resources, and global attention. Gates understands that tackling climate change requires thinking big and acting fast. By putting his name, money, and reputation behind natrium, he's sending a signal that nuclear innovation is not just possible, it's necessary. Energy security and geopolitical impact. Beyond technology and economics, the natrium reactor could reshape how nations think about energy security. Many countries currently rely on fossil fuels imported from politically unstable regions, leaving them vulnerable to price spikes, supply disruptions, and geopolitical tensions. Small, flexible, and reliable nuclear plants like natrium could reduce that dependence, allowing countries to produce vast amounts of clean energy domestically. For the United States, deploying natrium reactors means more than just electricity. It's a strategic advantage. With scalable reactors, the U.S. can maintain energy independence while meeting climate goals, and it can export the technology to allies, strengthening global partnerships. TerraPower isn't just innovating in the lab, it's contributing to national and global resilience, which is why projects like this are watched closely by governments, investors, and energy experts worldwide. Looking ahead, the first commercial natrium reactor is just the beginning. TerraPower plans to scale up, deploy more reactors, and continue refining the technology. If all goes according to plan, we could see a future where nuclear energy is modular, efficient, and integrated seamlessly into the energy landscape. A stark contrast to the large, centralized, and often slow-moving nuclear plants of the past. This is exactly the kind of breakthrough we cover. Technology that reshapes industries, challenges assumptions, and has the potential to impact millions of lives. Natrium is not just a nuclear reactor, it's a vision for the 21st century energy grid. So, will TerraPower's natrium reactor live up to the hype? Will Bill Gates' nuclear dream finally become a reality? Only time will tell, but one thing is certain. This is a project that demands attention. It combines cutting-edge engineering, visionary leadership, and urgent environmental need in a way few projects ever have. If you want to keep up with this story, along with other breakthroughs in energy, technology, and innovation, stay tuned to Here. We break down the future as it's being built, one revolutionary idea at a time.